Okay guys, it's me Imad. Today in this video tutorial we will learn about how to interface or how to simulate an ultrasonic distance finder or ultrasonic sensor with that of esp32. So how we can do that? First of all, we need to open Google and here you need to write wokwi. Wokwi is actually an online simulator, so we need to click on wokwi.com. Now it is open and now we need to search for our esp32 microcontroller. So click on esp32 and we got two of our windows, okay? That is, one is the circuit window while other is the coding window, okay? So on right hand side we can build our circuit, on the left hand side we can write our code, okay? Now first we will make our hardware, that is the circuit. So we will search for ultrasonic sensor, okay, and here we got our HCSR04 ultrasonic sensor. You can see 4 of its pins, okay? That is VCC, which must be connected with the 3.3 volt of esp32. Then there is ground pin. Ground must be connected with the ground pin of esp32. Then we need to have trigger pin, okay? Now trigger pin must be connected with the D5 pin of esp32. You can change the trigger and echo pins, okay? It is not always mandatory to connect this trigger with D5 and echo with D18, okay? And here we will write to connect this with D18, and now our circuit has been completed. Now we come towards our code and on wide setup. But first you must know that how this ultrasonic sensor used to work. There are two parts, okay? One is the transmitter thing, and it is a speaker like thing, and one is the receiver, okay? One is transmitter of the sound, ultrasonic sound, and one is the receiver of ultrasonic sound. One side or one speaker used to send ultrasonic signal and other used to collect it out, okay? And then we will calculate the time, okay, time duration as well, okay? We know the speed of sound is 330 meter per second. We all know that. And this, what's called as the time, will be calculated when we used to collect it out, okay? So as we know that speed is equal to distance by time, so distance is equal to speed multiplied by time. If we have speed and time, we can find the distance. So this is the basic principle. Now in wide setup, we will write int t_p, okay, is equal to 5. We are just declaring two type of variables, okay? Int e_p is equal to 18. Although this is not a necessary step, but still we are doing it, okay? T_pin means that wherever we need to declare pin number 5, we can write T_p and it will mean pin number 5. And where it is E_p, it means that it is pin number 18 or GPIO number 18, okay? After this, we have to define one more variable of float data type, okay? Float data type, and that is SS, that is speed of sound. Here it is 0.034 centimeter per second, or I think, yeah, it is centimeter per second. So it is 0.034, okay? It is just a constant here, okay? Speed of sound is 0.034. Now we will write long. Long is another data type, and we can write DUR, and that is duration, long duration, okay? So this our, now duration means the time duration, okay? Time duration and speed of sound. Okay, because we want to, these are just the variables. We want to store certain values in all these variables with different name, t underscore p, e underscore pss, and duration or duration, or what is. Okay, and one more thing, that you can change the name of these variables if you want. Okay, float dist. Now float dist underscore cm means that distance in centimeters. Okay, float actually now dist underscore cm variable can store float type data. Okay, that is, even if the numbers are in decimal, it can store it out. Okay, integer cannot store the decimal number. Okay, now we will come towards void setup. Okay, void setup. So cl dot begin 11,5200. Okay, this is our baud rate, and we are not supposed to write any other thing like this. Okay, here we will also need to declare our pins, pin mode, that which pin is input and which pin is output. So t underscore p is our output. Okay, what is output? Trigger is our output, while e underscore p is our input. E underscore p is our input. Now output and input, t underscore p, e underscore p, input and output. Okay, now our one pin, that is pin number 5, has been declared as output. You can directly write 5 as well, and e underscore p is declared as input pin. Okay, so now we will, in while loop function, which used to execute again and again. So here we will write digital write. Okay, now we will create our sound signal. Digital write t comma p low, t comma p comma low. Okay, means that it must be low or 0 has been sent on t underscore p pin, that is pin number 5. Then we will delay for certain microseconds. Delay. Okay, wait, we can write delay microseconds. Okay, and how much? 2 microseconds delay must be there. And then okay, and we need to write t comma p high. Okay, after this has been done, we need to write t underscore p high. Okay, because signals are always highs and lows. Okay, these are digital signals, and it consists of zeros and ones and like this. Okay, but for how much time? Okay, it will be decided by this delay microseconds, and then we will write 10 microseconds. Here we will write 10 microseconds. Okay, okay, now after this has been done, we will make our t underscore p low. Okay, t underscore p low, delay 10 microseconds, and we will write t underscore p low. Okay, now this has been done. We will write durn, that is duration, is equal to pulse in e comma p, e underscore p comma high, e underscore p comma high. Now this function is very important here. Pulse, it will find that for how much time, our e, okay, e underscore p becomes high. For how much time? Okay, it will calculate the time and store inside this duration a variable. Okay, and after this is, we will write dist underscore centimeter is equal to durn multiplied by ss divided by 2. Okay, because we have taken this divided by 2 to like minimum, or we have divided this SS on 2, okay, because it will go and I think it will return, so that is why they have written this 2. Okay, the sound used to strike the object and then it will come back, so maybe, so that is why they used to write this divided by 2. Now, okay, now we will write serial.println that what we see, we will write how much distance they has. Okay, oh sorry, wait, distance is equal to, and then then we can see dot print and then println, and here we will write dist underscore centimeter. Okay, now this is our, okay, wait, this is our whole program. Now we will see how it used to work. Now wait for some moments. Okay, what the side expected this, yes, we need semicolon, so these errors are quite common in all the programming. Okay, now we are compiling and wait until the project used to compile. Now you can see that we got on serial monitor 399.94. okay, now we will reduce the distance and we got 337 point, means that now we can measure the distance with the help of our microcontroller. So hopefully you got the concept that how you can interface or how to simulate an ultrasonic sensor with that of esp32. So thanks for visiting our channel and don't forget to subscribe.